Hello, welcome friends. Let's start from 66 number question because in our previous lecture we have completed up to 65 number question. Okay, so 66 number question, as you see this question, okay, it comes from the Boolean algebra. Okay, so how can you solve this? It is an easy question. So you have to know some basic properties like when you multiply any input A into B plus C, then it will give AB plus AC. Okay, like this, A dot A bar, that is A complement A. When you AND get it, it will give 0 because 0 AND get 1 or 1 AND get 0, both will give 0. Okay, like this, when you add 1 plus, that means OR get with 0 or 0 OR get 1, it will give 1 always. Okay, so applying those properties, utilizing here, you will get 0. How you can get 0? Because in every terms there are 4 terms you are getting here. In every terms there are some input and its complement is present, like this in this term. As you see here, B and B bar is present, here C and C bar is present, here A and A bar is present. Okay, you see this term, so it will eventually cancel out. Okay, not cancel out, they will give 0 in all terms, so ultimately you get 0 as the output. Okay, so coming to 67 number question, this question is asked to find the wrong statement. Okay, so how can you do? Let's check each option one by one. Okay, in the option number A, it is given that when j equal to 0, k equal to 0, clock pulse have no effect. Okay, let's see how can you solve this. So to solve this, you should know about the truth table of JK flip flop. Okay, this is the truth table. Now you see, it is given that when j equal to 0, k equal to 0. Now you see where j equal to 0, k equal to 0 present. This is one condition where j equal to k and k equal to k. But you see in the upper position there is also a condition is present, because this cross sign means j and k can be anything. It can be 0, it can be 1. So there may be a condition, there may be a situation when j equal to 0, k equal to 0, and in that position, at that position, this clock is equal to 0. And when the the lower, that means this j equal to 0, k equal to 0, this in this position, this clock is on. Okay, that means in this case the clock is 1 means clock is on, but in this case the clock is off because the clock is 0 means it is off. Okay, so in both the situation, you see what is the output. This is the output, this is the qn plus 1 is the next output. Okay, and q1 is the previous output, or you can say previous input. Q1 is the previous input and this is the next output, qn plus 1. Okay, so you see in both situation you are getting same result, qn. That means previous state. You see in the comment, in both situations you are getting previous state. Okay, so this option is a correct one. Okay, this option is a correct one, but we have to find the wrong statement here, wrong statement. Okay, so go to option B. In the option B, it is given that j equal to 0, k equal to 1 flip flop cannot be set. It will be in reset position, cannot be set. Set means s equal to 1, reset means r equal to 1. Okay, so when j equal to 0, k equal to 0, k equal to 1, you see when j equal to 0, k equal to 1, when j equal to 0, this j equal to 0, k equal to 1 means this condition, it is given that the flip flop cannot be set, it is reset. You see what is written here, it is reset. Okay, so this is also a option B is the correct one. Okay, but we have to find the wrong statement, it is the correct statement. Now you see option C. Option C is j equal to 1, k equal to 0. It is impossible to reset the device. At j equal to 1, means it is telling about this condition. it is telling about this condition. J equal to 1, K equal to 0. It is impossible to set it in the reset position. It is impossible to reset the device, which is also a correct one, because you see this is in set position. Set means it is impossible to reset. When you are qn plus 1 is 1, this 1 means it is set position, so you cannot reset. To reset you have to uh, go through this condition, the upper one condition. Okay, then you can get 0 here, then it is reset. Okay, so this is also option C is also a correct one. Now you see at j equal to 1, option D, j equal to 1, k equal to 1, it is forbidden condition. Okay, this is the forbidden condition. You see in j equal to 1, k equal to 1, j equal to 1, k equal to 1 means this 1 means, you see this clock 1 means it is in on position. Okay, the clock is on. J equal to 1, k equal to 1, it is giving q n bar means complement of previous state, complement of a previous state. But it is in the question, it is giving, it is written that this condition will eventually give forbidden condition, which is a wrong statement. Okay, so option D is the wrong statement. That means in the sense of this question, option D is the correct one. Okay, so how can you know that this is a complement of the previous state? For that you see this is the logic diagram of a JK flip flop. Okay, so when j equal to 1, k equal to 1 and clock is on, okay, let's suppose this q means previous state. Okay, this previous state, let we are letting it, let q equal to 0, then s, then you see when j equal to 1, k equal to 1 and q equal to 0, and you see where this q is connected, this q, you see this is the output for q, and this q is also we have given a feedback, we have taken a feedback from q and q bar also, and the feedback from q is connected to the lower AND gate. You see this is when this q equal to 0, and it is also giving to this AND gate 0. So whatever be the input of this lower AND gate, that is k equal to 1, and also you are giving q equal to 0. So q equal to 0 means this, and it is connected to the lower AND gate. So when any input of an AND gate is 0, then the resultant output is 0. But in the upper case, for this diode, the q bar, as q is 0, the q bar is what, 1, and 1 is connected to, you see 1 is connected to this AND gate. So j equal to 1 and clock is also 1, and we are giving 1 from, it is coming from q bar. So the AND gate result is also 1. Okay, so now you see in this condition s equal to 1 and r equal to 1, you see this result is connected to this, that means s equal to 1, r equal to 1. So when, and this is what, this is a SR flip flop. So when in SR flip flop s equal to 1, r equal to 0, it will give, you see when s equal to 0, r equal to 1, it will give this condition, means set. Okay, means set. So you are getting what, you are getting q1 plus 1, that means the next output is what, set, that means 1. You see 1. But in the previously what you have assumed, the value of q, you have assumed the value of q as 0, but you are in the output you are getting 1. Okay, similarly if you take this condition, j equal to 1, k equal to 1 and clock is on, but if you assume q equal to 1, now we are assuming it. Okay, in the previous condition, that means in this condition we have assumed q equal to 0, this, but here we are assuming q equal to 1, and if you apply this condition, you will get that s equal to, you will get s equal to 0, r equal to 1. Now you see when s equal to 0, r equal to 1, this, you will get this condition, means reset. where the Qn plus 1, that means the result of a previous, the next output is 0 here. That means when you assumed Q equal to 1, your next output is 0. But when you have assumed Q equal to, means previous state equal to 0, in the next output you are getting 1. Okay, set, this is 1. This Q means the next output, means Q n plus 1. So in those conditions, what conclusion we get? We are getting a conclusion that the this conclusion, that means we are getting the complement of previous state. You see, when we have taken Q is equal to 0, then you got the result as 1 next state. But when you have assumed Q equal to 1, in that condition, in the your next output is 0. So what you are getting? You are getting the complement. So this condition is the complement of a previous state. But in the question, it is given that it is forbidden. Forbidden is in case of which flip flop? Forbidden is in case of SR flip flop. You see, this condition, this option D is correct only for SR flip flop. You see, in SR flip flop, this condition is true. This is forbidden when J equal R equal to 1, S equal to 1. Okay, this is the SR flip flop. Okay, hope you got the answer. So option D is the correct one. Now you come to 68. In the 68 number question, it is asked to identify which are the universal gate. Okay, it is a easy question. Option D is the correct. That is NAND and or NOR. Okay, both are universal gate. Why these gates are called universal gate? Okay, why? Because any logic gates can be constructed using those two gates. Okay, how? You see, for example, to construct an AND gate, how many NAND gate or NOR gate we can use? Any idea? You see, to construct a AND gate, this is a, as you know, conventional non-AND gate. You give two input A, B, and you use a AND gate, you get a B. Okay, as a result. But how can you convert this in terms of NAND gate? This is the express. You see, you can use two NAND gate to construct the AND gate. How? You see, AB connected to a NAND gate, it will give AB bar. Okay, it will give a AB bar. Then you connect this output to another AND gate, NAND gate. Okay, then you will get this complement will be cancelled out. So you will get AB. Okay. Similarly, this is for the use of NOR gate. How many NOR gate you can use to construct a AND gate? 3 NOR gate we can use. You see, A connected to this NOR gate, it will give A bar. B connected to this NOR gate, it will give B bar, and both are connected to another NOR gate, it will give you AB. Okay, so in this case 3 NOR gate, in this case 2 NAND gate. Okay, so that's why the nature of this both gate, to use them to construct any logic gate. So this nature is known as the universality nature of these two gates. Okay, that's why they are universal gate. Now coming to 69 question, it is given that for optical mode in linear diatomic lattice vibration at k tends to 0, the phase difference between the oscillation of two atoms is, ultimately it is asked to find the phase. Okay, that means it is asked to determine whether these two atoms, let's suppose the first atom has mass m1 and the second atom has mass m2, and the mass m1 is smaller than the mass m2, means m2 is heavier than m1. Okay, so when what do we have to find? Whether these two atoms moving towards each other or they are moving away from each other. So in these two conditions, the phase is pi. Okay, they are in out of phase, they are pi in phase. But when the two atoms move in same direction, whether left simultaneously, whether right simultaneously, in this condition the phase is zero because they are moving in the same direction. So this condition we have to find whether they are moving out of phase or in phase. So how can you find? Let's see the solution. Okay, this is the 69 question. You see the dispersion relation. Okay, so when k tends to 0, the omega positive, you see this graph, this is the important graph, this is the dispersion relation omega versus k. You see when k tends to 0, this graph is for optical branch, it is given also for optical branch. Okay, you see this is written in optical mode, and this lower graph is for acoustic branch, sound related. This is for electromagnetic wave related. Okay, so what you have to find? The phase. Now you see at k tends to 0, this is the k axis. Okay, when k tends to 0 means this, when k tends to this means at this range, in this range k tends to 0, at these conditions, at these situations, what is the value of omega? In optical mode, you don't see this graph, this is for acoustic, you see this upper one, this is for optical mode. When k tends to 0, omega positive becomes this top one. Okay, it will tends to, the omega tends to this position, this value of that is 2 omega, 1 by 2 beta 1 by m1 plus 1 by m2 to the power 1 by 2. Okay, in the root of a term. Okay, and here the m1 mass is smaller than m2. Okay, so if you apply this condition to this equation, in substitute k equal to 0 and omega positive is this value to this equation. And where did we get this equation? We get this equation from Swiss. It is derived from the matrix formation using the Hooke's law. Okay, in Hooke's law, we used the Hooke's law to find the net displacement. From that we get the matrix, and that matrix simplification we get this equation. There are two equations. Okay, so if you put this value in this equation, you get and simplify this, you get this. After simplification, you get what? If you put omega positive 0, this, and this cos ka is going to 1 because k tends to 0. When k tends to 0, cos 0 equal to 1. So that's why this is 1. It's giving you 1. Okay, so after multiplication, this is simply simplified. If you do some calculation and simplify it, you will get this term will be cancel out because they are same. Then you will get a by b equal to minus m2 by m1, where a and b are what? The amplitude of mass m1 and m2 respectively, and beta is the spring constant. That means the two atoms, they are connected with some bond, and that bond vibrates with some frequency. Okay, and that frequency, that spring nature of that bond, okay, has some spring constant. That spring constant is beta. Okay, so you see in this equation what you get, what we are getting, that amplitude of a body or a atom is inversely proportional to its mass. That means if the mass of a atom is small, then its amplitude is high. Okay, or if the mass of the atom is heavy, the amplitude is low. That means here in this case m2 is heavier than m1, then m2's amplitude is small as compared to the amplitude of mass m1. You see, this is the case. Okay, so this upper one wave life structure I have drawn in black color. You see, this is for mass m1, which is a lighter mass, and you see its amplitude is much bigger than the amplitude of the red wave like structure, and this is for the mass m2. And in both situation, you see in both situation, when the time at which this mass m1 is moving upward, at that same time this mass m2 is moving downward. Okay, and in this next half, you see when the mass m2 is moving upward, at the same time this mass m1 is moving downward. So in this situation, what conclusion you get? We get the conclusion as that both mass are out of phase. When one mass is moving up, another mass is moving down. Or we can say when one mass is moving right, another mass is moving left. So that means what? They are these two waves, the first wave and the second wave, they are out of phase. And how much phase they have? Phase difference they have pi phase difference. You see, when one is at a some this, they are pi phase difference. Okay, so this is the question solution of 69 question, 69 number question. Okay, coming to 70 number question, it has given that in the choose the correct statement. Okay, so how can we choose the correct statement? We have to check each option one by one. Okay, so read the option number A. For monoatomic lattice vibration in long wavelength limit, phase difference is not equal to phase velocity is not equal to group velocity. For monoatomic lattice vibration, you see it is given that monoatomic lattice vibration. Okay, monoatomic lattice vibration, and there is no mention of a dimension. So let's take this is a 1D dimension. Okay, one dimensional. Now you see the solution. This is a 70 number question, and for monoatomic lattice vibration, this is the dispersion relation, that is omega equal to root over of 4 beta by m sin ka by 2, and this A is what? This is the difference between the atom and atom. Let's suppose this is one atom and this is another atom, and they are monoatomic. That means the mass are same. Okay, and they are arranged in this condition. Okay, or we can say there is a spring between them. So like this is one dimension. So, and this is the omega, means the vibration frequency. Okay, so when what is it has given the condition, the long wavelength limit means lambda tends to infinity. Okay, so when lambda tends to infinity, the wave number, that is k, which is related to omega as 2 pi by lambda, sorry, k is related to lambda as 2 pi by lambda. So when lambda tends to infinity, k tends to 0. Okay, so when k tends to 0, you put the point condition here. When k tends to 0, sin ka by 2 can be approximated to k by 2. Okay, this we have approximated this, and you again, if you put this condition again in the equation 1, what you get? You get this, and after simplification you get that omega equal to a into root over of beta by m into k, and this is nothing but the speed of sound in the medium. Which medium? The medium in which this monoatomic lattice is present. In that medium, the speed of sound is this. Okay, this is the speed of sound. So ultimately we are getting this dispersion relation. Now if you want to find the phase velocity is what? The speed of a single wave. There are multiple waves in the medium. So if you want to find the phase of a single wave, the condition is Vp equal to omega by k, this. And if you put the condition, that means if you take this k down here, okay, so omega by k will be Vs, that is the speed of sound. And now if you find the speed of group velocity, that means the speed of the collective wave, that is the speed of a envelope, that is there are multiple waves. Okay, so when they superpose, they will ultimately give a single wave. Okay, that single wave's speed, or you can say the envelope in which inside which all atoms speed, okay, is moving. Okay, above that there is a envelope. Okay, that means the totality there is a altogether the resultant wave speed, that is Vg, is a group velocity. So how can you find this? This is nothing but a d omega by dk differentiation. Okay, differential element of a d omega by dk. So if you differentiate this equation, what you will get? D omega by dk is also Vs. So what we are getting? We are getting Vp equal to Vg, group velocity equal to phase velocity equal to the speed of sound. Okay, this. That means it is a non-dispersive medium. Okay, this is a non-dispersive medium. What is a non-dispersive medium? Actually, a non-dispersive medium is that kind of medium in which the wavelength depends on its refractive index of that medium. Okay, so for example, if you take the case of let's suppose we are beaming a light in vacuum. Okay, let's suppose there is a torch and you on the torch in vacuum. So did you see do you see any dispersion? That means when a white light is passed in a vacuum, then did you see any dispersion of light? That means you are getting you are spending a white light, then you get seven different color, because seven different colors are constituted in white light. So did you see? That means you did not see. Okay, so in vacuum, when you pass white light, you do not see the seven component of the light. So when you will see this person when you pass white light in any medium. Okay, like you pass in a prism, in a white light, if you pass a white light to a prism, then in the other side you will get seven different colors. So this is the prism is a dispersing medium, but here it is given that this is a non-dispersing medium. That means what? That means the speed of a single wave and the speed of the resultant wave both are moving in the same speed. Okay, so option B is the not equal. It is given that not equal. That means Vp and Vg are not equal. But we are seeing that these are both are equal. So this option is incorrect. So we have to find the correct one. Okay. So come to option B. In the option B, it is given that for a diagonal lattice vibration, the forbidden gap is in frequency is from beta by m to 2 beta by m, where m is the capital M is the heavier mass and small m is the lighter mass, and beta is the force constant or the spring constant. Okay, you see the frequency is given that beta by m, and this is impossible because there is no root term here. Okay, there is no root term. There should be a root term. There should be a root term. Okay, because frequency is in this term. We can convert this frequency in this term. There should be a root term. But besides that, if you see the solution, actual solution, you see this is the diagram. This is the for optical and this is for acoustic. And it is given that to find the actually it is asked to find the gap. That means this forbidden gap, this gap, this gap. Okay, this is gap. Okay, that means this is the gap. What is this gap? This is starting from 2 beta by m2 root over 2 and ending in 2 beta by m1. M1 is the lighter mass, M2 is the heavier mass. So as it is heavier, it should be in the lower position, and as this M1 is lighter, it should be placed in the up position. So this gap is the forbidden gap. But it is given that beta by m. In the first case, in the first situation, there is no root over here. So this is incorrect. But if there is let's suppose root over present, then it is in the notation that beta by capital M. There is no 2 here. You see, let's suppose there is root term present here, but there is no 2 here. So this option B is the incorrect statement. Now coming to option C, it is given that in the acoustic mode, masses move in the same direction with the equal amplitude when k tends to 0. You see, this is the it is given for acoustic. You see, this is for given for acoustic in mode masses move in the same direction. Acoustic mode, it is given that in the acoustic mode masses move in the same direction with equal amplitude when k tends to 0. You see, when k tends to 0, when k tends to 0 means this one. Okay, k equal to 0 means what? This. K tends to 0 means in this region. When k tends to 0, 0, the two masses move in the same direction. We see how the two masses move in the same direction. Now you take this condition. This is the equation. Okay, as I have mentioned that these equations are calculated using the matrix simplification with the use of a Hooke's law. Okay, so when k tends to 0, omega negative. You see omega negative here. That means we are denoting this omega negative means for acoustic. Positive means that means omega positive. Whenever we write omega positive, that means it is for optical mode. Whenever we write omega negative, this is that means it is for acoustic mode. So when omega k tends to 0, omega negative tends to 0. You see this this graph. When k tends to 0, when k tends to 0, omega, this is the omega. Omega tends to what? Omega tends to 0, because when k tends to 0, omega tends to 0. You see this graph, only this graph, this is acoustic. We are not mentioning this optical mode here. In the question, it is asked to the case for acoustic. You see, this is the acoustic. So don't see this person. You see only this person. Okay, this person. Not see this. Okay. So when you see, so what? When k tends to 0, omega negative tends to 0. Okay. So if you put this one condition here in the equation, then you will get a what? You will get a by b. That means the amplitude of mass m1, whose mass is less than the mass of m2. Okay, so a by b equal to tends to 1. That means the amplitude of both heavier mass and smaller mass, lighter mass, both are same. Okay, and there is no negative sign here, and this is a positive sign. You see, 1 means what? There is a positive 1. But in the condition before, if you see, as I have calculated somewhere, okay, I think in this condition, okay, you see in this in this case, this is for optical, and here we have got a negative sign here. You see, negative sign, m2 by m1. That means what? They are out of phase. But in this case, we are getting, what? Positive 1. That means they are in phase, and the amplitude of both waves are same. Then the wave looks like a single wave. You see, this is a single wave, but in this single wave, both atoms are vibrating in same direction. You see, this is this is the mass m1, and this bigger one is the mass m2. They are moving in the same direction. Okay, or they may move in the right direction, or they may move in the left direction, but they are moving in the same direction. So that's why this is not out of phase, this is in phase. Okay, so it is given that in acoustic mode, mass move in the same direction. It's okay. This is also true, because mass are moving in the same direction and with equal amplitude. This is also equal. This is also correct one, because you see, a by b. This is, that means the mass of amplitude of mass a and divided by the amplitude of mass b. Both are equal, giving to 1. That means both have equal amplitude. Okay, so this option A, option C is the correct one. Okay, so coming to option number D, that is, it is given that as heavier mass increases, the acoustical branch is parallel to k-axis. Okay, so when the heavier mass, that means m2 mass increases, whether the graph tends to branch is parallel to k-axis. We have to see whenever the graph becomes parallel to k-axis, when the d omega by dk, that differential quantity becomes 0. Okay, that in that case only we can say that it is parallel. Okay, now we see the solution. You see, this is omega negative square. This is for acoustical branch or modes. In that case, this is negative. When we talk about optical modes, then this is positive. Here you see there is a negative here. This is for this present only in acoustical branch, but for optical branch this is positive. Okay, this is positive. So if you put now we are taking two conditions. That is, one condition is k tends to 0, and another case is k tends to infinity. When k tends to 0, you see the graph, this graph. When k tends to 0, from that may be from positive infinity to 0, or that can be negative infinity to 0. In both the cases, this graph is acting like a straight line. You see, in this range, k tends to 0. In this range, you see, it is tending, it is acting like a straight line. You see, this is straight line from this to this or this to this, and after some value up to some value of k, this is acting like a linear. It is increasing linearly, but after some time, this is becoming a curve like structure. You see, from this to this, it is becoming curve. But up this up to this point, in k value, it is increasing linearly. Okay, so that means what? It has some angle. It has some angle with k axis. When you speak that this graph is parallel, when this graph is like this, and the k axis is like this. Okay, this is k axis. When this graph is like this, then we can say that this graph is parallel to k axis. But as it is making some angle, okay, as it is making some angle, that means it is not parallel. Okay, now see the second case. That means the k tends to infinity. Okay, when k tends to infinity, you see, when k tends to infinity, that means this is the when k tends to infinity, this it is for this range. Okay, when k tends to infinity, it looks like that it is becoming parallel. But if you know that this is a this is a range of a fast Brillouin zone. This is the range for fast Brillouin zone, and this range is from minus pi by 2a to plus pi by 2a. And after this range, the second Brillouin zone starts. Second Brillouin zone. Okay, this side also and this side also. And the graph of this, and their graph is like this. Okay, like this. And here also the graph is like this. Okay, now you see, it looks like that at k tends to infinity, it is becoming parallel. But at that time, at that position, that is pi by 2a or minus pi by 2a, it is becoming 0. But after that, it is jumping. It is starting from pi by 2 to 8 from this value. There is a band gap. This band gap is the energy band gap. That means we can say from valency band to conduction band. There is a band gap. That band gap is this. Okay, this is the band gap. And in this range, when k tends to infinity, it looks like that it is parallel, but it is not. I don't know, I have some doubt, but it may not be parallel. Or let's suppose it is parallel, then this initial condition, it is not 0. It is not 0, it is making some angle. So at omega m2, when mass m2 increases, then this initial condition, that means when k tends to 0, this is not giving you 0. That means at this condition, it is not parallel to k axis. When k tends to infinity, in that case maybe it is parallel. But to the option for the option D to be correct, both conditions should be satisfied. That means when k tends to infinity or when k tends to 0, in both cases, when you put m when m tends to infinity, in both cases it should be what? Parallel to the k axis. The graph should be parallel to k axis. But for k tends to infinity, for k tends to 0, it is not parallel. It is making some angle. You see, this is the angle. Here is also some angle. That means it is not parallel. You see the graph. This is the graph. You see only in this range it is looking like that it is parallel to k axis. But in this range it is not. So this option is also a incorrect statement.